You can't really look inside the human brain.
And in your case, who knows what we'd find?
But we can see where the thinking takes place in your PC, in the microprocessor.
Let's say you ask your PC for a file. Your hard drive sends data to RAM and then onto the microprocessor.
Sometimes we make it easy and just call it the processor.
Thanks. The processor is the brain that handles the actual work, forming words, creating graphics, and so on. In many PCs, the processor gets help for certain jobs. A math coprocessor, for instance, may do the heavy arithmetic.
Or the video board may have a special chip to handle the graphics of Windows software. But just what is this processor?
Well, several types are in use today. Older computers have processors made by the Intel Corporation, named the 8088 and the 286.
These chips seem very slow to us now.
Chances are the PC you're using right now is powered by at least an Intel 386 processor.
And don't forget about memory. Get it? Forget? Memory?
I get it. Organizing memory is one of your processor's biggest jobs. In fact, the 386 was the first chip that could handle memory for complex new operating systems like Windows and OS/2.
A newer chip, the 486, tops the 386 with special new math circuits and with an added memory buffer to hold code in reserve.
But time marches on. The newer Pentium processor is faster still. Instead of one arithmetic logic unit, or ALU,
Oh, brother, that's the part of a processor that executes code.
the Pentium has two ALUs, so it can perform two operations at the same time.
But wait, there's more!
The PowerPC processor has the advantage of using less power, making it a popular choice for portable PCs.
It's actually called a RISC chip, for Reduced Instruction Set Computing. That makes it not only use less power, but it runs leaner and meaner. And that's what I'd call risky behavior. Why is it that when you put a new blank disk into your PC, well, you usually have to wait while the disk is formatted?
Here's why. Most disks come out of their box totally blank. Formatting draws a sort of grid on the disk surface, so the operating system will know where to store and read data. This grid divides the disk surface into pie-shaped sections.
Pie.
Control yourself. It also creates many concentric rings called tracks.
Well, don't the tracks and the pie sections overlap?
They do. The areas where the two intersect are called sectors. You might say that section A and track 1 combine to create sector A1.
And these sectors become the building blocks the PC uses to store information?
Very good. Two or more sectors make up a memory cluster.
Like a chocolate peanut cluster.
Sort of. A cluster can also be called a block, as in blockhead.
Oops.
A big file might use hundreds or thousands of clusters strung together. On the other hand, even if a file is only 1 byte long, the computer will use an entire cluster of 256 bytes or more to hold it. The PC couldn't keep things organized if it tried to subdivide clusters.
Well, so how does the PC keep things organized?
Good question. When the disk is formatted, DOS creates a special file allocation table, or FAT.
Are you calling my DOS overweight?
Not at all. The FAT keeps a complete map of the disk, where each file is stored, which clusters are in use, and so forth.
Oh, sort of a disk information book.
Right. When you ask your PC to find a file, DOS checks with FAT to see where it is stored. And when you add a new file, FAT knows where empty space is to store the new bytes.
Bytes, clusters, pie wedges? I'm getting hungry.
I can see that. Just be sure you don't get fat.
Very funny.
Let's take a look at your input and output devices.
Which ones exactly did you mean?
Not yours, the PC's.
Oh, well, in simple terms, a PC is really just a box which you give information, which then gives you information back. This information or data can be words, numbers, or simply images.
You need a way to give the computer data, that's input. And a way to get information back out, that's output.
All the devices that let you do this are naturally called the input, output, or I/O system. Typical input devices, that is, ways you can send messages to the computer, include the keyboard, the mouse, the joystick, and the scanner.
Output devices include the monitor, the sound card and speakers, and the printer.
Some elements can be both input and output devices. A modem, for example, both sends and receives data.
Another vital I/O device is the bus.
You mean like the wheels on the bus?
No, wrong bus. This bus is the circuitry on the motherboard that carries signals between your I/O devices. The drives, the processor, RAM, and the ports on the back of the PC.
So, if you want more output on the bus or any other part we've talked about, just jump off this bus and check it out.
Thanks for your input.
You may think of your computer as one big memory bank, but all PCs actually have two ways of storing data.
The first is on drives or disks. The second is on a variety of memory chips. Let's look at disks and drives first.
All PCs have at least one floppy drive. It may not seem very floppy, but that's just the hard outer case. Inside where the data is stored, the disk is made of flexible plastic coated with magnetic film.
Another drive that just about everybody has is the hard drive. It's the real storage workhorse of your PC. The disks in this drive are made of a hard metal or glass.
Because it spins faster than floppies, the hard drive can write and retrieve data faster.
Multimedia PCs have a third type of drive, the CD-ROM. While floppy and hard drives store data magnetically, a CD-ROM drive uses a laser beam to pack up to 650 megabytes on a single disk.
Wow, that's about 400 floppy disks worth.
Now let's look at memory chips.
Now, when you work at your PC, data is temporarily stored on chips called RAM, or Random Access Memory. They're stored here because chips are much faster than disk drives. They work electronically, not magnetically.
But this also means chips need constant power. That's why if you turn a computer off without saving your data to a disk, it's lost for good.
Or for bad, depending on how you look at it.
The RAM chips shown here are called single inline memory modules, or SIMMs. In other words, several chips are mounted on a small strip of circuit board to make it easier to install or change memory.
Your PC has two other types of memory chips. The instructions that tell your PC how to handle data are called the Basic Input-Output System, or BIOS. BIOS is held in a set of read-only memory chips. That's ROM. It's called that because the code has been permanently etched in the chip's circuitry.
Even more information about your system hardware is stored in a CMOS memory chip. Unlike a permanent ROM BIOS chip, data in a CMOS chip can be changed. This is what you do when you upgrade your system.
What?
You edit the data in your CMOS chip, among other things. So in sum, your computer isn't one big memory bank.
Well, it's a bunch of different little memory banks. Back in the old days...
You mean when you were a kid?
No, actually only about 10 years ago. Multimedia used to mean anything that combined two media. A slideshow with background music, for instance.
When we talk about multimedia PCs, though, we're looking for a computer that can sing and dance. That is, one that can play music,
Sound effects,
animation,
or video images.
all at once.
To be a true multimedia machine, a PC also needs a CD-ROM drive.
Why the CD? Well, sound and video use a lot of memory. The sentence I'm speaking now, for instance, uses 141 kilobytes of disk space.
At that rate, a few sentences barely fit on a floppy disk, but a CD-ROM disk can hold up to 650 megabytes. That's like 400 floppies.
The thing is, you can't save your own data to a CD. The ROM part stands for read-only memory. But since you can take out one CD and put in another, you can build a huge library of information.
And games.
Absolutely. Now, another essential element of multimedia is the sound card.
Your sound card translates digital code from the CD-ROM into the analog signal of electric current. Now, this current vibrates the codes in your speakers, and you get good vibrations.
The final multimedia element is video. Any VGA card will display video. How well depends on the speed of the card and of your PC's processor.
Now, if video seems jerky and crude, your system probably isn't fast enough. In video, the images change 30 times every second.
On a slower computer, though, the PC saves memory by skipping over some of the frames.
Another trick we can use to cut processing time is to fill only a portion of your monitor screen, like this.
But new techniques like MPEG compression let PCs display video full screen and without skipping frames. That's what's called full motion video. Compression also dramatically cuts the enormous amount of space needed to store video images. Without compression, a single minute of video might fill a whopping 1,800 megabytes.
Wow! And that's not multimedia, that's massive media! How does your PC run a program? Well, let's say you want to use a word processor called WildWords. When you type that program's name,
or click its icon, your PC's operating system looks through the hard drive for a file with that name. If it doesn't find one, it'll start checking your disk drive.
Once found, the operating system copies WildWords to RAM. This lets the PC work with the file without having to go back to the hard drive every other second.
Now the operating system tells the PC's processor where the new program is in RAM. The processor reads the file, and you're off and running.
Or typing at least.
Now, when you use this program to start a new file,
or make changes to an old file,
both the processor and the RAM are involved.
As you work, your file is temporarily stored in RAM. When you click Save, the file gets copied from RAM back to permanent storage. That is, back to the hard drive. As you can see, the more RAM your PC has, the less often it has to go back to the hard drive, and the faster everything runs.
That's why, as the old saying goes, you can never be too rich or have too much RAM.
That's an old saying.
It is now. When you wake up in the morning, your brain remembers who you are.
I'm not sure I want to know.
Checks to see how you feel.
If it's Monday, I know I don't want to know.
And gets ready to face the day.
Not.
Something a little more successful happens when you turn on your PC.
Yeah, only without the morning breath.
Enough. In your PC, this is called the POST, or Power On Self-Test.
When you hit the on switch, the power supply fires a burst of current that wakes up the processor and tells it to look for startup instructions.
Those instructions are found in the chips of ROM BIOS, the read-only memory basic input-output system.
Oh, that's a mouthful. What's for breakfast?
The ROM BIOS chips carry the POST, which now begins.
Right. First, the chips double-check their own code against the same code stored in memory. If everything's okay, the POST proceeds.
The test looks at all the expansion slots, plus the serial and parallel ports to make sure they're working right. And it checks the system's clock chip.
When the POST gets to your video adapter, you may see a message about your video BIOS.
The POST also checks the keyboard port to see if a keyboard is attached and whether any keys have been pressed. Next, the POST writes data to all the RAM chips, then reads it back to double-check for their accuracy.
And the POST keeps going. It now checks to see what floppy and hard drives are installed, comparing these with a list in the CMOS chip. Finally, all systems are go. Now the actual boot up process begins.
Is there a disk in the floppy drive? The processor checks. If there is, the PC uses the operating system on that disk to boot up.
If not, the PC looks for boot up files on the hard drive.
On this drive are two hidden system files, usually named io.sys and ms-dos.sys.
Wait a minute. Secret files hidden on my drive?
That's right. You normally don't see them, but the system can't boot up without them. Now we get a sort of chain reaction. The PC loads a small bit of data called the boot record into memory. This record loads the io.sys file.
And the io.sys loads the ms-dos.sys. And the ms-dos.sys loads the config.sys.
That configures your system.
And the ms-dos.sys also loads the command.com.
The command.com has standard built-in commands such as copy.
And the command.com looks for a file named autoexec.bat.
The autoexec.bat is a set of special programs you want the PC to run each time it's turned on. If command.com finds such a file, it carries out those instructions. Otherwise, it presents the familiar C prompt.
Is that it?
That's it.
Well, that's some wake-up call.
I thought you'd get a boot out of it.